Hello, welcome back. And as what should be becoming a familiar pattern to you by now, we're going to have a segment on solving problems using the concepts that we've introduced in the previous segment. And this one is on solving problems using functions. And as usual, I'll tell you, when you look at the spec, at least sketch it out and maybe go and solve the whole thing yourself, and then follow through with me in the solution that I come up with for that particular problem. Here's your first spec. Well, the first spec is really not so difficult. We're going to define a function called largest, and it will take 3 int parameters and return the largest of those 3. So the computation is not all that complicated. What is the largest of 10, 30, and 20? It's pretty obvious that 30 is the largest. So here's an example of how you will call the function that we define. 2 examples, actually. The first one says pass in pass in the literals 10, 30, and 20. So this function is defined to take 3 ints. You can give it 3 int variables, or you can give it 3 int literals, or you can give it 3 expressions that evaluate to int. It really doesn't matter, so long as when you call it, you give it 3 arguments separated by 2 commas, that each one is an int value being passed into the function. And this function, when it returns, it will return with the largest of the 3 ints passed in. And in both of these cases, the variable big would then have the value 30 in it after the function returns. So let's go into the development environment and solve this problem. This one you may want to solve yourself. So if you want to pause now and go and solve it based on this specification, that would be a good idea, or you can watch me solve it as well. I've created a new function called a new project called largestfunction.c, and what we want to do is to let's just declare 3 variables, first, second, and third, and put in the values that were on the slide. And then let's declare another variable to hold the result of the function call. Now we can call the function, well, we can write the function call even though we don't have the function yet. So we're looking for the largest of these 3 arguments. So we're passing in 3 values, 10, 30, 20, and we want the largest of those to be returned by the function. So let's go back up above the main and make the definition of the function. So what we have now is the function call, and the definition of the function, well, it needs a return data type. So we're going to make the return data type an int, and the function is called largest, and it takes 3 ints, and you have to name each one of them with its own data type. So you can't write int a comma b comma c. You have to give each one its own data type, even if they're all the same. So there's the function with the open and closed braces. And now you don't have to do it this way, but this is my preferred way. Whenever I write a function that has a return data type other than void, I declare a variable called result, and then at the bottom I return the result. And then in the middle I just have to figure out what is the result that will get returned. So this will compile all the time, let's make sure that it does. So even though the function doesn't do anything yet, let's just make sure that this compiles. With F7, and we have one succeeded. So we could call this function now, but it wouldn't do anything useful. And what we want to do is write the logic in here that finds out which of A, B, and C is the largest. So how will we do that? There's any number of ways. How about if A is greater than C and B is greater than C, then the result no, my logic is backwards. If A is smaller than C and B is smaller than C, then what do we know? If both A and B are less than C, then the largest must be C. How about else if A is less than B and C is less than B, then the result is B. And one other possibility, if B is less than A and C is less than A, then the result gets A. I wonder if that logic is correct. What would happen if A, B, and C are all the same value? What would you want to return? Well, any of them would be as good as the other, but none of these would actually evaluate to true because we have only less than, not less than or equal to. So I'm going to anticipate that bug and make all of these less than or equal to. And I think we don't even need the last one. Well, let's leave it like that for now anyway. We'll walk through it in the debugger and see what happens. First, let's compile it and see if we have any mistakes. So we have one succeeded. That's a good sign. I'm going to put a breakpoint here. And I'm going to run to that breakpoint so we can make sure everything is doing what it's supposed to be doing. So first has 10, second has 30, and third has 20. And these are called the arguments. We're passing the arguments into the function. Let's step in, step into, and when we're in the function, we have the variables a, b, and c. And these variables are the parameters to the function, have accepted the values that we passed in as 10, 30, and 20. Okay, so now we have if 10 is less than 20 and 30 is less than 20, is that true or false? Well, 30 is less than 20 is certainly false, so the answer will not be C. Let's step and make sure that we don't go into that if. We did not. Now we have 10 is less than 30 and 20 is less than 30. That seems to be true. So if we step, we're actually setting the result variable now to 30. and we didn't do the else part because we found that the largest of the three numbers is 30, and that's the value that will be returned. So when we execute this return statement, we're going immediately back to the caller with the value that's in there, which is right now 30. Something that I haven't made a point of before is that when you define a function, you're defining a place where you can declare local variables. So this variable result is not available in the main function. And these variables, first, second, third, and big, are not available in the sub-functions. So the variables that are declared inside the functions are for local use. That means that they're only available here inside of those functions. That's a very good thing, because if you break up this work among 5 different programmers and say everyone write their own functions that do things, and you would have to coordinate what variable names have already been used. And we can't have that. It would just be too awkward. And we only want these modules, to be independent of everything else. So we're going to have variables declared inside the modules as available only there. Okay, let's go back now and say when we execute this return statement, we're going back to the caller and we're going to finish executing that statement, and the variable big now has 30. So when we passed in 10, 30, and 20, we got back 30 as the biggest one. So you can see now that the main function logic is really very simple. We have only this one line of code, but you can still read it. You can tell what it's going to do. It says, give me the largest of these 3 things. I didn't output anything, so there will be nothing on the output except press any key to continue. And I wanted to make a point of the fact that you can pass in anything you want. I mean, you can pass in literals, or you can pass in any combination of literals and variables, so long as this function call is given 3 values, 3 arguments that can be passed into these 3 local variables in the function. Let's run that one, passing in 45, 23, and second. Second has 30 in it. I hope we get back the answer. 45 is the largest. Is it going to work? Here it comes. We've hit the breakpoint. And now we're going to step into the function. And we have in A 45, and in B 23, and in C we have 30. So passing in this variable as opposed to a literal doesn't make any difference. We're still going to run this function with the variables A, B, and C. So 45 is less than 30, and 23 is less than 30. Well, that's not going to be true, and the next one's not going to be true, but the third one is. So we will return A, which has in it, we're going to return result, which has the original value of A, which is 45. So as we go back to the caller, big now has 45 in it. Okay, if you implemented this in your logic, doesn't look like that. It really doesn't matter so long as it worked. That's kind of, if I thought about it, I might come up with something a little bit different from that, but that's okay. This one is fine. Let's go and look at another specification now. Well, this specification is going to pull together a bunch of concepts from the entire course, and it's going to take a little bit of time. So I want you to type along with me and keep up with me because putting it together at the end will be quite difficult. Let's have a look now. We're going to ask the user to enter daily rainfall amounts, and we'll start out with 5 and maybe change it to some other number later. And the spec also says only allow positive rainfall amounts. So it doesn't really make sense to say we had -1 inch of rain today. So when the user enters a negative number, we're going to tell them that that's not valid and have them enter another number. The next thing we're going to do is to calculate the total rainfall and the average rainfall. This should be familiar from a previous segment. And we're going to determine the largest daily rainfall and the smallest daily rainfall. That's also a familiar specification, but now they're all coming in one. And we're going to output the total, the average, the largest, and the smallest using some informative messages. So this starts to get fairly complicated. I don't want to try and get my head around all of this at once. So the first thing we'll do is we'll start off with looking at a test case. And if we can't imagine how the program output will look, we probably can't write the program to make it do that. So that's the starting place. Here's the input data. Suppose the user enters 1.7, -1.9, -23.4, and so on. The expected result, this shows what the program should do. It's going to ask for a rainfall value, and if the user enters a negative number, then the program will ask for another one. So that's why, even though we said we're going to use 5 values, there are actually 7 numbers here, because 2 of them won't be used. We're only going to use the positive ones. So after the user has entered the value, this very polite software says thank you, and then it outputs the total rainfall, the average rainfall, the largest daily rainfall, and the smallest daily rainfall. Okay, I will only want to work on one piece at a time and make sure that that piece is working and then move on to the next piece. So let's start to decompose the problem into modules and make an abstract solution. So here's my abstract solution for this. I'm going to make some functions. I'm going to have a function that gets one rainfall value from the user and returns that. And you'll see why I've done this as I solve it. But I'm going to call that one 5 times. Each time I call it, it will give me back one valid rainfall amount. And then I have a function called calculate the total, another one calculate the average, find the largest, find the smallest, and then output the results. So the main function will have much less congestion in it because we're breaking the entire problem into all of these sub-problems. Let's go to the development environment and start to solve this. And I'll flip back and forth to these slides so that we don't lose track of what the spec was. Okay, well, let's take a crack at this spec. I'm going to flip back and forth between the development environment and the slides that give the specification. So I've created a new project in the development environment called Rainfall Functions, and I'm going to now go in and start adding the code. So let's make a rainfall.c and put in the includes. Here's the main function. And let's put a system pause in here. We don't really need one probably, but we've been doing that all along. So the first thing that we're going to do is to ask the user for 5 rainfall values that are doubles. So we'll kind of declare variables and define things as we go along. So let's do a pound define size, which will be the number of values that we're going to collect, and we can change that whenever we want. So we're going to declare an array of double rainfalls that has size elements, which will be 5 for now. And then I want to ask the user for a valid rainfall amount. So let's say rainfall sub 0, and I'll change that later, get rainfall, get valid rainfall. Is that what I called it? So there's a function call whose job is to go out and get a rainfall amount from the user. And return it so that it can be stored in the array. Yes, there's the function name I had decided on, get valid rainfall, and that gets one value from the user. So let's go back and implement that function. So it's going to return a double value, and its name is get valid rainfall. And what is that function going to do? Let's declare the result and return the result. And then in the middle, we can do whatever we need to do to get the right result. So let's do a prompt to the user. Enter a rainfall amount. And I'm going to put a \n at the beginning of that one. And now we're going to scan it in. Scanf %lf result. Now remember that we need to check to see if the user gave me a positive or 0 value. So a negative number wouldn't be acceptable here, and we want to bury that detail inside of the function getValidRainfall. So I could write an if statement that says if result is less than 0.0, it's a double, then ask again. So I guess we better put out an error message, printf, and I can't remember what the error message is supposed to be. So let's go back here. Is not a valid rainfall amount. Please enter another rainfall. Okay. %.2LF is not a valid rainfall amount. That will tell the user what's going on. And then enter another rainfall amount. Okay, so if the user enters something that's less than 0, then we'll tell them that's no good, and we'll ask them to enter another one. And then when they do that, we'll return the result. Do you see any problems yet? Well, let's compile and see if we've made any mistakes that the compiler doesn't like. And I have 2 errors. That's good. We have a chance to learn from this. What are the mistakes? Unresolved external. Unresolved external means that you have called a function that doesn't exist. Oh, and of course, it's a typo in here. Get valid rainfall. One succeeded. That looks better. Okay, let's run this and just see if that function call is actually executing and giving back a number. So what we're doing is we're trying to bury all of the detail into the sub-functions so that in the main, what does the main do? Well, we ask for one valid rainfall amount. And that's very easy to understand without seeing any of the detail. So let's run this, F5, enter a rainfall amount. Suppose we enter one that isn't good, negative 2.4. Oh, 0.0 is not a valid rainfall amount. Enter another rainfall amount. And there's a bug on that output statement. We didn't include the variable. And here's another problem. Suppose I enter another negative number right now, negative 3.1. Well, it's happy with that negative number when it wasn't happy with the previous negative number, and that's a problem. So let's fix these problems. The first one is output the value to match this %.2 LF. And what's the other problem? Well, we got a negative number there, and the phone's ringing. So the problem is, when we got a negative number here, we recognized that problem, and we asked for another one. So the problem right here is if someone enters 2 negative numbers in a row. Well, I'm sure that a lot of you have figured this out. Why don't we just change this to a while loop? So we can say while the result is less than 0, then keep asking for another value until we get a positive one, and then we can return that. So all of this detail of interacting with the user is stuck in this method so that we don't have to deal with it in here. So in the main, now what we want to do is to make a loop that will fill up that array with valid values. So I'm going to make a for loop that says for I gets 0, I is less than size, I++. And there it is. The rainfall values are collected into the array and they're all valid. So now we don't have to think about anything else to do with the input-output, and our main is still very small and very clean. Let's flip back now and find out what our next requirement is. Well, once we get the valid values, we want to total them all, find the average. Now, we have a method called calculate total, and another one, calculate average. That method, calculate average, is looking pretty small right now. Let's make a method called calculate total, and it will return the total rainfall. Total rainfall gets calculate total, and I'm going to leave this argument list blank for a second, and I have to declare the variable total rainfall. Now, here's something that we haven't looked at before. We have a function that returns a double, and we want it to take an array of doubles. So we want to pass in this array. And we haven't done that before. So I'll show you that when you pass an array to a function, you use the square brackets in the parameter list, but not in the argument list. And we're going to pass in the size of the array. And I can pass in the constant size, which is 5 currently, but it might be changed to a larger number if we want to collect more data. So now we can implement this calculate total, and it's a pretty simple function. The result initialized to 0.0, and then a little for loop. We need an I for the for loop. I gets 0. I is less than size. And result plus gets rainfall sub I, and then when the loop is over, return the result. Okay, so there's the code that would calculate the total of the array passed in, and it takes the size of the array so that we can use that in the loop. Well, I'm going to change my mind on the fly now, because calculating the average rainfall doesn't look like it needs a function. Average rainfall is the total rainfall divided by size. And what else did we need? We need to find the largest, find the smallest, and output the result. Well, I'm going to implement the largest rainfall. My keys are repeating sometimes. I get double letters. So largest rainfall will be set to what is returned by a function called find largest. Find largest will take the rainfall array and the size. This should be familiar to you. We can put the function up here. It will return a double, and it's called find largest. and it takes an array of doubles and the size of the array, declare the result. We want to put the largest one in there, and I can initialize that to 0.0. We need a control variable for the for loop. I get 0, I is less than size, I plus plus. Now we'll look at each one and we'll say if rainfall sub I is greater than result, then result gets rainfall sub I. And then after the loop is over, return the result. And that should be the largest value in the array. Okay. I wonder if I've made any mistakes. Have you spotted any bugs yet? Let's compile this. One succeeded and none failed. Well, let's output the results. And maybe I won't make a function for that either. I was intending to make a function just for the purpose of outputting the results. I'm going to leave that for you as an exercise. I'll just output a couple of them here. The total rainfall is, and it's a double, so let's put %.2 LF total rainfall, and then we'll output the average. Oops. Average rainfall and largest rainfall. Is that the wording that was in the spec? The largest daily rainfall is, the average daily rainfall is, the total rainfall for these 5 days. So I'm drifting away from the spec, and that's kind of sloppy. I should have had a copy of this beside me while I was working on it. The largest daily rainfall is one place past the decimal. Largest daily rainfall is %.1 LF \n quotes, comma, largest rainfall. Let's compile this and make sure that everything is still working. And let's watch it run in the debugger. So we kind of looked at this first part where we get the values, so I'll set a breakpoint after that, and we will run using the test case data. How will I get the test case data? 1.7, negative 1.9, 1.7, negative 1.9, it should complain about that. And another negative, it complains about that. So we have that part working. 2.5, 0.0, 2.5, 0.0, 0.3, and 1.0. And we've hit the breakpoint. Good. So let's look at the values in the array rainfall. And there they are, the 5 values that we've entered. And calculate the total. If we step into that method, we can watch the calculation of the total. You can watch the variable result go up, and it seems to make sense. So we've got 5.5 so far. So we're going to return the total as 5.5. And when we get back here now, we see that total rainfall is 5.5. Average rainfall, we opted not to make a method out of this because it's just too simple. So we'll step over that. Average rainfall is 1.1. The largest rainfall, let's step into that one. So we're in the method called find largest, and we're looking for values bigger than the largest so far. So 2.5 seems to be the biggest so far. And we are going to return 2.5 as the largest rainfall amount. And that's what goes into this variable here. And then the output of those values, let's see if this seems to match our expected result. The total rainfall is 5.5. The average rainfall is 1.1. The largest daily rainfall is 2.5. And the smallest daily rainfall was not calculated. So I left that one out. The function is very similar to the largest one, and I'm going to leave that to you as an exercise. Okay, I'm going to make this as big as I can now and I'll show you all of the code for these functions in case you have been typing along and I'm going too fast. So here's the getValidRainfall function. And you can see the other two functions, the calculateTotal and the findLargest function. Let's have a look at the concepts now that we've gone over in these segments on functions. The hard part about functions really is to decide what the function should be and how to break the problem into functions. That takes a lot of practice, and sometimes when I have a first design, I don't really get it right. And during the implementation, I changed my mind a little bit. So we had that experience in the previous demonstration where I was thinking about making a function to calculate the average, but then it was only one line of code, and I decided, no, I'm not going to do that. So you kind of allow this to unfold as you're going along. So take a crack at it and then see how it goes, and you change your mind a little bit, and that shouldn't worry you. Functions, when you define them, they should do only one thing, and they should have some documentation that describes what they do. We didn't put any documentation, any comments on the functions, and that's kind of a mistake. Well, that is a mistake. We should have written some code that, some English that describes what the purpose of each function is. It's very important that as you're working on larger problems that you work progressively. You should never be working with code that doesn't compile. So just a few lines of code and then compile it and make sure that that works, and then a few more lines and compile it and make sure that works. And as you get better and better, the few lines of code become a few more lines of code as you get more confident with the syntax and the semantics, what the code is going to be doing. Writing a whole lot of code that doesn't compile really is just causing problems for yourself. You now have to go and look for the errors. Deciding what what information needs to be passed into the functions, and what information the functions need to pass back to the caller. This also requires practice, and this practice is not really a concept. Remember, this is a concepts class, so understanding the concept of getting information into the function and getting information out of the function is what we're most interested in at this point. This is called coupling, how the functions interact with each other, how they couple with each other. And it also takes some practice. That's kind of a skill that gets developed with number of lines of code written. A few more on this next slide. You should be able to write your functions so that they can be reused in other applications. Once you've solved a problem in a function, you never have to solve that problem again. You just reuse that piece of code. That's really quite powerful when you think about all of the code that's ever been written. You should be able to just reuse all of it if it's been written carefully, modularly, and in well-defined functions that do only one thing. The syntax for passing arrays to functions in C is really quite tricky. So until you've practiced this several times, keep a working example nearby for reference. I think there isn't any reason to guess what the syntax is. Where did those square brackets go? And there isn't any way to figure it out. It doesn't really make sense. It's just the way it is. So keep an example of one that works near you until you can do it without referring back to one. That's the only way to not waste your time passing arrays to functions. And in this concept summary, oddly enough, I have one of the concepts that we haven't covered. As we come to the end of this course, we have not covered pointers in C, and that was intentional. Pointers are very important in C and C++, but the implementation in C and C++ is very specific to those languages. So I'm not going to cover pointers at all, and in a C class or a C++ class, you will cover pointers a lot. So there's the trade-off. If you need to be a C programmer or a C++ programmer, then you need to be in a class that covers C or C++, and you absolutely will need to understand and be able to work with pointers fluently. Well, this is the end of the video segments for the Programming Concepts class, and I want to thank you for all your feedback and your watching these videos. I'm quite surprised by the level of interest that seems to be coming from all over the place. That something that doesn't seem very complicated, but just to sit down, I mean, as an instructor, it doesn't seem very complicated, that it would be a good idea to sit down and make an explanation of these things so that people could look at them over and over and wouldn't have to be in a classroom to hear someone describe them or demonstrate them. It didn't seem very complicated to do, but it seems to have had a bigger impact. I think that's probably when you know that you're on the right track, that something that doesn't seem complicated gets a big reaction. So what I would like you to do is to take the time to send me some email and let me know how you felt about these video segments. What was easy, what was hard, what was a waste of time, and what was very useful. The things that you find that weren't good, didn't suit you, would be the most valuable comments, because then I could correct those in future versions. Thanks a lot.